All right, class, this is lesson 5.2, perpendicular and angle bisectors. We're going to learn how to use the properties of perpendicular bisectors and angle bisectors here. Go ahead and pause at any time. Check back for the answers. All right, theorem 5.2, perpendicular bisector theorem. If the point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. All right, so if line PM is perpendicular to segment AB and AM is equal to MB, then PA is equal to PB. All right? And the converse of that, if a point is equidistant from the endpoint of the segment, then it is on the perpendicular bisector segment. So if we're going to complete that diagram to show that, then the line that is, we'll just draw a straight line here, and we'll move it, we'll go through the point P, and since the distance from P to R is equal to the distance from P to T, this line right here must be the perpendicular bisector. So that also tells us that those are congruent. All right. So we're going to use this here and find out what is MN. Now, given this diagram, we know that segment OM is perpendicular to segment NP. We know that because of the right angle. And we also know, since this distance is the same as that, and it's a right angle, that it is that OM is the perpendicular bisector of NP. So given that information, we could say that MN is equal to MP by the perpendicular bisector theorem. And so we can just substitute. We get 6x minus 1 is equal to 3x plus 8. And then we can use our properties of equality to solve that. Maybe a subtraction property of equality, take away 3x from both sides. Use the addition property of equality and add 1 to both sides. Use the division property of equality and get x equals 3. Now we know that MN, the length of segment MN is 6x minus 1, and we can now substitute 3 for x, and we get MN is equal to 17. All right, go ahead and pause and try that problem, see if we can figure it out. Okay, so problem 2, the monkey bars are located midway between the slide and the tether balls. Which the following are about equidistant from the slide and the tether ball. So if it is equidistant from the slide and the tether ball, and the monkey bars are located midway, so that's this, those segments are congruent, then we draw the perpendicular bisector, and the way we would do that to make sure it is we would use our compass and to draw the perpendicular bisector. This is just a little reminder here. The perpendicular bisector is the segment here to that, and that. And we can switch sides. And draw a line through there. That line shows us that anything on that line is equidistant from the slide and the tether ball. So the one thing we see that is on that is the monkey bars. And we did that using the perpendicular bisector theorem. We know that this point would be equidistant from both of those. All right. So in this problem, we got to go ahead and draw PS. So I'm going to just take a straight edge and draw a line through P and S. And that is, hopefully that's close enough. A little bit off, but get the right idea here. Here, maybe I can fix drawing. All right. So anyway, we want to put in a T-shirt stand, and we want that to be equidistant from the spaceship chute and the rolling coaster. So if it's halfway between those, and he's already drawn the line L for you, that's halfway. So any point on that line will be halfway between points R and S. All right. And now the T-shirt stand, we want to be equidistant from those two and the paddle boats. So we want to know what some possible locations would be. So we drew PS there, and on the diagram, any point that is on the perpendicular bisector of PS would be equidistant from the paddle boats and the spaceship. So we need to draw in a perpendicular bisector there. So we need a compass. My compass from earlier. And I'm going to draw that and spread this up a little there. Okay, so draw that line. That line. Switch sides. Draw that line. That line. And then we're going to take a straight edge, draw a line from there to there. And now anything on that line is equidistant from the paddle boats and the spaceship chute. So we got that. And that is the perpendicular bisector. Of, yes. All right, so does the line you drew intersect line L? Yes, it does.
Where should the t-shirt stand be placed so that it is equidistant?
It should be placed right there at that point, because that point is equidistant from these two, as given by,
It's on the perpendicular bisector of those 2 points, R and S.
and it's also equidistant from P and S. So all of those points are equidistant. All right?
So, perpendicular bisector theorem, if the point is on the bisector of an angle, then the point is equidistant from the sides of the angle. If point S is on the
Angle bisector of angle PQR, then SP is equal to SR.
and the converse, if a point is on the interior of an angle, is equidistant from the sides of the angle, then the point is angle bisector.
One thing you should remember is the distance is given by the line that's perpendicular. So whenever we say the distance, we mean the shortest distance, which means it makes a perpendicular line with that other line. So point S is in the interior of angle PQR. If SP is equal to SR, so if we're given this, then S is on the angle bisector. That angle. All right, so we're going to use this theorem, angle bisector theorem, to figure out the length of OP. So we know that O is on the bisector of angle MLP, and we know that because of these marks here, that they're congruent angles. So we know that. We also know that this line is perpendicular, so that this represents one of the distances, this represents the other. And by the angle bisector theorem, we know that this line is congruent to that line. So we know MO is equal to OP, and that's by the angle bisector theorem. And so we can just substitute for MO and OP. And we get 3x is equal to 12 by using the subtraction property of equality. And by using the division property of equality, we get x is equal to 4. Then we know that OP is equal to 3x plus 12. That's a given. So we can substitute for x the number 4 and simplify, and we get 4. All right, go ahead and try these, and then we can check back for the reasons. And there's your answers. And the lesson check. Perpendicular, congruent, non-congruent. So AC is perpendicular bisector BE. Make sure you understand that. You have to identify which is actually a perpendicular bisector, but this segment is not congruent with that segment. Okay, that's the lesson. See you tomorrow.